Okay, now that we've covered scope and parameters, and just to remind you, scope basically indicates where we can use variables based on where they're defined, and parameters are simply the temporary variables that all methods need to do their job. That's it. Today we're going to go into the idea of creating our own methods. So the topic of today is something called subprograms. Sub means a part of. So a part of a program. Well, that's what we're looking at. Part 3, procedures. Now, if you're watching this at home and you're following along on PowerPoint, please realize that this PowerPoint is meant to be used in actual presentation mode. If you're just looking at preview mode, it's probably going to look pretty ugly because there's a lot of animations and things like that and whatnot. And if you're not following it properly, it's probably going to look pretty ugly and cluttered, and you may not get the right information. If you're looking at it in Google Preview mode from our classroom, it's definitely not going to look right because there's a lot of alignment things. So download it first and then open it on your computer to view it from that point. Okay, so moving on. What's our objective today? We're going to learn about subprograms, what they are, how to define them, and how to use them. So our introduction. Imagine, I'm going to go through this with you ad hoc here. So imagine for a second that it's the end of the semester. And the principal, Mr. Brzezzi now at this point, when I'm creating this video, Mr. Brzezzi has 400 students that are about to graduate. Well, with each one of those students, they all get a diploma. And each one of those diplomas has something nice at the bottom. It has his personal signature, handwritten signature, that says, yes, I acknowledge the fact that this student has achieved all the requirements to graduate. Here is your piece of paper that you can show to the world. And that's fantastic. But 400 is a big number. 400 things to sign is not only going to take a lot of time, it's actually going to be physically painful. You've all written really long essays and stuff like that where you're just constantly writing and writing and writing and writing. And if your hand's doing the exact same motion, it's not just that it's a long piece of document, but it's actually the same motion, so it can actually be harmful to your wrists and things. Anyways, wouldn't it be nice if there was a way to actually speed up this process? Well, in fact, there is. There's something out there called a notarized stamp. A notarized stamp is like a legal rubber stamp copy of somebody's signature. And that signature, that rubber stamp copy, can be used in place of the real thing. That's a huge deal and brings up a huge benefit. So think about it like this. The benefit of the stamp is that you only have to create it once. But as soon as it's created once, you just need to use it. You just put it in the ink, slap it on the page. Bang, 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 as many times as you want. You could get through those 400 diplomas like that. No time flat. In fact, Mr. Brzezzi wouldn't even need to be the person to do it. He could hand that stamp and those documents off to somebody else who worked in the office. Now, of course, I don't know how much he wants to hand out a legalized stamp of his name, because that stamp is required for things like checks and whatnot. So maybe not so much trust-wise, but anyways. It is physically possible for him to hand those documents and that stamp over and him not have to do anything. The only thing he was a part of was the actual creation of the stamp itself. So that's our goal today. What we're going to do is we're going to try and create our own stamp, the equivalent of that stamp in our programs. We want to put a little bit of extra effort up front to create a grouping of logic. And then whenever we want to use that grouping of logic, we're just going to stamp. Put it in its spot. No problem. And as we can do it as many times as we want. Well, that's what a method is. In fact, you've already seen these before. You've seen them in things like console.writeLine, console.pow, and things like that. Now let's go into this a little bit more detail here. So the stamp, which is also called a subprogram or a method. Now these two terms are interchangeable. You're going to hear them depending on which online resource you're looking at, which textbook you're reading, sometimes depending on what language you're working with. So if you're working in Java, it's almost always called a method. Subprogram is kind of like the accepted term for everything in that regard. Some languages call them functions. It depends. I don't like to use that term because we're going to be using it for another thing coming down the line here. So to formalize the definition of what a subprogram or method is. A subprogram, sometimes referred to as a method, is a program within a program that performs a single task and can be reused to perform that same single task as many times as desired. Well, is that not almost the exact definition of a stamp? Something that performs a single task and we can reuse it as many times as we want? Well, that's what we're doing. We're going to create our own version of a stamp. Now, you see this idea of a program within a program. Well, there's that sub-program notion there. So a program within a program that performs a single task that can be reused. Great. So up until now, we've called these things code blocks. And I briefly touched on the term method in the previous lesson. And I'm going to go back and forth between these terms because I need you to realize that they both basically mean the same thing in our program. So I want you to be able to be comfortable with both terms. Don't get confused by them. They're the same thing. Subprogram, method, same thing. Okay? So what kind of subprograms methods have we dealt with before? Write line, POW, read line. Even the main method is itself a method, right? It's called the main method. Are all examples of methods that someone else created for us to use in our program. So they actually created the stamp. We're basically borrowing the stamp and smacking it in our programs as many times as we want. I could do write line 50 billion times in my program. Doesn't change the results. All I'm doing is setting the values of what's going to be written on the page. That's it. So we can use these subprograms potentially many times in a single program. That's pretty useful when you get down to brass tacks on this stuff. So, much like that principal stamp, before he can ever actually make use of it, he's got to first spend a little bit of time up front to build it. He's got to create it. Then as long as he's got ink, the stamp can actually be used forever. Now that's a pretty important notion. As long as he has ink, it can be used potentially forever. Now, what is ink? In our big analogy, we said we're creating a stamp, but what would be the ink to us? What do we need to do the job in our subprograms, our methods? Well, that's where our parameters come into place. Ink for the stamp is the same thing as parameters for our subprogram. It's something that's needed for the stamp to do its job. That's it. Okay? So, as I said, this is the same for methods that we create. We must first define the method, much like we do a variable, before we can actually refer to it by name later. Now, when we think about it, you said define it. Define? What do you mean define? Define the method, sir. Well, we defined our variables by quickly stating what they were. That was it. And then it was just added to the C# dictionary. But what did we really create there? Well, we really created a bucket to hold data. So what are we creating when we define a method? Well, in this case, we're creating a bucket to hold instructions. So instead of holding just one little piece of information, it's holding a series of instructions. And every time we call that method, anytime we refer to it by name, it's going to execute every single one of those instructions in order. That's important to realize. And as I said before, the parameters are basically the equivalent to ink in our example. No difference there. So there are two kinds of methods or subprograms. And this is why I don't like to use the term function for subprograms, because that's actually one of the types. So there are two types of methods we're going to make use of. A procedure, which is going to be today's lesson, and a function, which is going to be the next lesson after this. And there's really not much difference between the two. In fact, there's only really one difference between the two. So tomorrow's lesson is going to be much quicker. So for each one of these things, we are going to clearly show how to define them, where to define them, that's always important, and how to call it within our programs. Call is the term we say to execute. So I can call a variable, which really means just retrieve the value. I can also call a method, which means retrieve those instructions. And almost like copy and paste those instructions right there on the spot. And it says execute. Well, okay. How? What does that actually mean? Let's take a look. The first one we're looking at is a procedure. Quick definition. A procedure is a mini program within a program that performs a single task. That's it. It just does one job. If it's doing more than one job, you're doing too much. One job. So for example, write line. It does one thing. It displays text on a screen. It does nothing else. Absolutely nothing else. It just displays text on a screen. So how do we actually create our own? Well, it's not too bad, actually. It's a pretty straightforward thing. So here is our general syntax, the general look of the code when we want to define a procedure. Now remember, this is not using the procedure. We are just creating the stamp here. So all the yellow stuff you see here is stuff you're going to change. All the white stuff stays exactly the same. So private static void. And then we're going to give it a name, an identifier, just like we named our variables, an identifier. Inside of these brackets are each one of the parameters we're going to specify, if it needs any at all. And then we have our opening and closing brackets. Anything inside of these brackets is code that is executed fully, from top to bottom, whenever the method is called by name. So let's make a quick example, just so you can see this. Private static void output user info. So I've given it a name. And you'll notice the naming convention here. I'm not using camel case. I'm using mixed case, like the same way we name our programs. Mixed case. Inside of here, you see me define two brand new variables. Those are my parameters. They're being defined. We see a type and we see an identifier. Brand new variables. They're temporary, which means when this closing bracket is hit, those two variables are deleted, gone. Inside is my logic that's going to execute every single time we call this subprogram output user info. It's going to say display on the screen name and then the current value that's stored inside this variable. And then age and then the current value that's stored inside this variable. You might be like, well, what value is in there? Well, that'll depend on when we call the function. What value, or call the procedure. What values are we going to give to it? You'll see that soon. So let's break this down so you can actually understand what's going on here. Everything here has meaning. So first up, you see that keyword static. We have to put that static in there because just like our global variables, this thing is defined outside of the main method. So anything we want to use inside the main method has to be static. So we have to put that static keyword there. Void is the word that tells C# that we're creating a procedure. The difference between a procedure and a function. So this tells C# that this is a procedure. Okay? Next up, we have our identifier. And the identifier rules for a subprogram or a method are exactly the same as our identifier rules for a variable, with the exception that we use mixed case instead of camel case. Mixed case just means every single word starts with a capital. That's it. The name itself, still, the most important part of this is that the name must be descriptive of the purpose. In this case, output user info. There is absolutely zero question of what this thing does. It outputs the user's information. There's no question there. If there is a question, you need to rename it. Great. So on the side here, we see our parameters. So this is where we're going to define our parameters. If you don't need any parameters, you're just going to put the round brackets there and leave them blank inside. There's nothing wrong with that. Not all subprograms actually require data to do the job. Okay. Inside here, we have our code. Now again, this is the code that's executed every single time we call output user info by its name. Every single time. There's no variation to that at all. So let's take a look at this. Where do we actually define these things? Well, we define our methods outside and underneath our main method. So if this is our program right now, this is our basic program, class, main class, public, static, void, main. This is how all of our programs look when we first create them. Where are we going to define our subprogram? Right below there. So it has the same indentation as the main method. Okay? But they're both contained inside of the main class. All right. So now we see that they're in line. So if I have more methods that I want to create, they would just go below there and just keep going down and down and down, all with the same indentation. Great. So in this case, this program simply defines, but it never actually uses output user info. Output user info isn't done. So if you ran this program, it would do diddly squat, nothing, zip, zilch, nada, because there's no functionality. The code executes from the main method, but there's no code inside of the main method. It's like we created the stamp and then put it in a drawer and forgot that it exists. That's all we did right here. That may not be useful. So now we know how to define them. We know where to define them. But how do we actually use it? It's time to stamp. So we can freely use it as many times as we want. So to call or use a method, we simply refer to it by its name. Just like when you call writeLine, you just refer to it by its name. You just say writeLine. Well, for your own method, you just call it by its name. So we have to as it says here, we simply refer to it by its name inside another method, like the main method or another method that we create. So we can actually call our methods from inside of other methods that we create. This may be pretty useful for depending on what you're doing. So if the method has any parameters, we have to satisfy the contract. Remember the contract? The contract says that the method will only do its job if we give it the data that it needs in the order that it needs it. So the next two slides are going to show us how to do this. And I'm going to do this using two different methods. The first method is giving the data, the parameters, values using literal data, actual numbers and things like that. Numbers and words, things like that. Whereas the next one is going to use variables. And we're going to see the difference between the two. And I'm going to show you how the memory changes as we go through this. All right. Now we see the entire program here. In the main method, we've called output user info 2 times. The first time with the name Bobby, or the name Bob, and the age 17. The second time with the name Judy and the age 23. Over on the side here, I've created a representation of what our RAM looks like, our memory. So you can see how things change as we go through the program. Down below, we have our stamp. We have our method, output user info. So every single time that this output user info is called, it's going to jump down into this method and execute everything it needs to do. Down at the bottom here, I have an example of what the console is going to look like as we go through our program. So let's give this a go. What's the first thing that happens? Well, the name and age variables are defined. So the program is executing now. It's actually on that first line. It's saying output user info, which means it jumps down into private static void output user info. This line right here, this private static void output user info string name int age, every single method has one of these things. It's called a signature line. And the reason why it's called a signature line is because it's unique. It's unique to this method. It has a unique name. It has unique parameters. Okay? That's why it's called signature line. Sorry, off track. So starting over again, it calls the output user info subprogram. It jumps down here and it says, all right, I'm going to do this work. Oh, I'm following along. Oh, I need to define a variable called name, and it's a string. So we define that variable called name. It's a string. Define another variable called age. It's an int. Okay. So 2 variables now exist in memory, but neither of them have a value at this point. They've just been defined. But the next command says, put Bob and 17 inside of those variables. So Bob gets copied into the name variable, puts up in RAM. Age, 17, goes into the age variable, gets put up in RAM. So right now, we have those 2 values in there. Next thing, the data is displayed on the screen because it comes down into the code and it says, all right, display the name, name : name. So it's going to jump over to memory. It's going to grab the value Bob. It's going to come back and replace it, substitution rule. It's going to do the same thing for age. So we get name : Bob, age : 17. Now this is where things get interesting. It's going to get to this bottom squiggly bracket of the output user info subprogram. And what did I tell you happened to temporary variables? They get deleted. So they're completely out of the RAM. The RAM is clean now. The RAM is completely clean. So the code comes back up here, says I'm done with this line. Time to go down to the next line now. So it comes down the next line, and guess what it does? It defines name and age again because it just started all over. Those variables were deleted. It came in here and it's defining 2 new variables, just happens to have the same names. So name and age get added to our RAM. It's going to follow the same pattern here. This time, Judy gets copied into the name variable and 23 gets copied into the age variable. So we have that. Then it's going to come down inside and it's going to display the new name and the new age. So we get Judy 23. So we've just called the exact same subprogram twice. And we just stamped it down on the page twice, but with different data. So if you want an example of this in terms of stamps, if you've ever seen those old school librarian stamps where they can change the date on them, but they still, that is basically what this is like. This is like the same stamp, but we're just changing the values that are actually stamped using that stamp. That's all we did there. That's what the parameters help us do. And then finally, it gets down to this closing squiggly bracket again, and what happens to the data? deleted. So that's the entire functionality. And that's using literal values. Things change a little bit though when we're using variables. Sorry, I lost my train of thought there. So when we're using variables. So let's take a look at this example. Now for this example, I'm going to draw on the screen a little bit so you can see this. Instead of me doing the crazy animations of doing all that stuff, which takes forever, I'm going to manually draw on here so you can see all this stuff. Okay, so looking at still the exact same code. The only difference is, you see I have a stamp. We're still calling our output user info 2 times, but this time we're doing it a little differently. You notice here this time I've created 2 variables, username and user age, and I gave it the value Fred and 21 respectively. Then I called output user info. Then below that, I'm actually overwriting the values of username and user age with user input. So we're retrieving it from the user this time. So I have no idea what those values are going to be. Who knows? Who knows what the user types in? And then we're going to call output user info again, but this time with whatever the user typed in. So it's important to realize how all these variables are going to work together. So let's take a look at this. So the very first thing that's going to happen, there we go, is username is defined and it's going to get the value Fred. So over here on the side here, oops, I gotta get my pen going here. Let's use green. There we go. So over here on the side, I'm going to create a variable called username. Pardon my amazing handwriting. All right, and it says it has the value Fred. Next up, we're going to create a variable called user age. So we just did this line, and now we're doing this line here, and we're going to store the value 21. So user age has the value 21. Okay. Now it's going to come down to this third line. And this third line, it's now trying to execute this method. So it's going to jump down here, down to the signature line, and it's going to follow along, and it says, oh, I need to define 2 new variables. I need to define a string called name and an int called age. So name and age are defined. So name, then age. This is where things get interesting though. So now what happens is Fred is copied from username. So out of here comes Fred. And then the next line, Fred is then stored into the name variable. So it's going to get popped into here. Now be very clear on this. I said Fred is stored in the name variable, not username. Fred is. So the value was pulled from username, copied. We copied Fred, and then we stored the copy into name. So that means that there's 2 versions of Fred inside of memory right now. The first one, which is in username, and the current one, which is in name. They both exist. Now the next line of code, or the next 2 things, do basically the same thing for user age. So user age is copied, and then it is then stored into the age variable. Okay, I think I'm gonna overwrite my stuff here. Where's my eraser? Do I get an eraser? Oops. Give me. Oh, there we go. Eraser. Let's get rid of the copy word here. Otherwise, I think we're going to be overwriting things here. And back to our pen. Okay. So, the next thing is the data is displayed, because what happens is right after we've defined those variables and stored the data, it comes down into the program and then runs these 2 lines of code. So it puts name and the current value of name, which is Fred, and the current value of age, which is 21. Okay. It comes down to this line, and what happens? What happens? Well, I'm going to need my eraser for this because, oh my goodness, really? I wish there was a quick one for this. There we go. I need my eraser for this because what happens is on the next line, name and age are both deleted. So age, gone. Name, gone. So with all this stuff. So right now in memory, username and user age are still there. Only name and age were deleted. So the next line, we go back up. Let me go back up here. Give me my eraser back, or my pen. Come on. There we go. So it comes back up. Says, I finished that work. Moving on with the rest of the program, please. And it retrieves the username from the user. So the very next line, it retrieves the username. It's read in, and it's stored into the username variable, whatever they put in there. So let's say they type in Judy. So that means Fred goes away. This is now Judy, because we just overwrote the variable. Username is equal to the next, whatever the user typed in. And down here we said it's Judy. And then the same thing happens to age. And let's say they put in 23. So that gets destroyed, and 23 is now sitting in the memory. All right. So these next two lines are executed. And then finally we get down into the last output user info call. So what's it do? Well, it jumps over to here. And the first thing it comes over, it says, oh, I need two variables. I need a name variable and an age variable, please. So it defines name and age. And then it's got to copy the values, because look at here. We are saying take the value from username and store it into the name variable. Take the value from user age and store it in the age variable. So it's a copy. So that means that username is going to get copied into name, and user age is going to get copied into age. So Judy is copied, and then 21, 20, that's, oh, no, 23, yes, 23. 21 was the old data. 23, oh my goodness. Can't write. 23 gets copied in there. Okay, we're almost done. So now it's going to come into the code, and again, it's going to execute and execute. It's going to display Judy 23 on the screen. And we see name Judy, age 23. And then finally, what's it do? It comes down to this final semicolon, or final squiggly bracket, and it does what it did before. It goes and it deletes. Where's my eraser? It's going to say, oh, I do not need this anymore. So name and age are gone. And this is where things really get interesting. So name and age are deleted. And then it gets to that, it comes all the way back up the program again. Wish there was a hotkey to do this. It comes all the way back up, but this time it comes back up to here. And then it goes down, it says, oh, I am done with the main method. So as soon as it's done with the main method, any variable that was created inside of the main method, oh look, string username and int user age are deleted. Is there a way to I wonder if I could click on that. Nope, it's not working. I don't know. Anyways, so that means username and user age are now deleted. So that's it. So we got a completely different experience from this when we used our variables. And you notice the same thing though. All it did was copy the data into those parameters. But inside, the program, the subprogram itself didn't care what values were in there as long as there were values in there. The regular program decides what values actually get in there, not the subprogram. Okay, so that is a procedure. It does one single task. It doesn't do anything else above and beyond that. So why do we use subprograms and methods in the first place? What is the point? Well, there's actually two main reasons. The first one is reusability, and that's that idea of using that stamp over and over and over and over again. So we might have a simple subprogram like you saw here with only 2 lines of code, or we might have a subprogram that does 100 or 1,000 lines of code. Well, if we can not do that 100 or 1,000 lines of code in our program, and we have to call it many, 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 many times, that's a lot better than having to rewrite and copy and paste those lines of code every single time. So here's my simple example. Creating a program that calculated the grade average of every single student in the school. It would take about 5 lines of code per student. You have your variables, you have your sum, you have your average and all that kind of stuff. Let's say about 5 lines of code per student. Well, if we have, let's say, 1,500 students in the school, Is that right? Maybe not 1,500. Less than that. No, 1,500 lines of code. 1,500 students in the school. You're looking at 7,500 lines of code to calculate the average for every student in the school. Well, now let's assume that we, instead of writing and copy and pasting those 5 lines of code for every single student, we created a subprogram that had those 5 lines of code. The parameters being the student's marks, and the work being that it calculates those averages. And that's fine. So instead of having 7,500 lines of code in our main program, we're going to have 1,500 lines of code, because we're only going to call that method one time for every student. And then for every one of those times, it's going to jump over to the code and do all 5 lines. Now, you might be saying, but it's still executing 7,500 lines of code, Mr. Lane. Yeah, it is, but we're not writing 7,500 lines of code. We're writing 1,500 lines of code. And I don't know about you, but I would rather save the 6,000 lines of code and the headaches. So reusability is the big one. The next one is actually very similar to the same reason that we use constants. So we use constants typically as like a nickname, like when we have pi or when we have gravity and things like that. We use it to represent a specific special value. And the reason why we do that is because we don't want magic numbers that really don't mean anything in our program. So by putting the name there instead, it makes our code more readable. I know what that 3.14 represents. I know what that 9.81 represents. It means something. So it has a name. So it makes our code more readable. Well, for programs, for subprograms, readability is the second reason. So much like constants, we can take a huge chunk of indecipherable code. In constants terms, it's just a number that who knows what it represents. But in subprograms terms, we might have a huge chunk of indecipherable, ugly code that is really complicated. And let's say it's right in the middle of right in the heart of our program. And who knows how long it is? It might be 20 lines, it might be 300 lines, I don't know. It doesn't really matter. We could take all of that ugly code, put it into a nice, well-named subprogram, and then in our main code, all we have to do is call that subprogram by name. And as long as it's well named, it cleans up that main code a massive amount. It makes it much, much more readable. Now you might say, but that other code still exists. Yeah, it does. It certainly does. And if I cared enough to go look at that code and figure out how it works, I could, and I have the option to do so. But in the main code, if I'm just trying to figure out how the logic of the program works, all I need is that nice descriptive name that tells me exactly what it's doing. It might be something like do collision detection. Well, that's a terrible name. It might just be like collision detection. And that code might do all the collision detection between all the different characters in my video game that I'm making. All right? So readability. Much like the use of constants and variables in the place of magic numbers, that should be of magic numbers, we use methods to clean up complicated code. Even code that is only done once in a program can benefit from methods. Imagine having code that handles applying physics in your game. So things like, kinetic motion and things like that. That code can get really, really complicated. But by putting it into a well-named method, you could replace that complicated code with one simple call to the method, making the main code itself much more readable. And that is the heart of what we're actually looking to do, is making sure that our code is readable. So basically, to summarize this whole statement is, we're going to use it, A, for reusability. So if you're ever doing something in your program more than once, it should have a subprogram. And B, for readability. If it's complicated and it's ugly, take it out, put it in a subprogram, and replace that ugly code in the main code with just the subprogram name. You might need the parameters too, depending on how complicated it is. But that is the idea of procedures, subprograms, how we use them, where we use them, when we use them, and why we use them. The next lesson is going to go into that next step. We're going to take it one step further and talk about functions. But that's it for now.